Hello, in today's video, we are going to be looking at our third heat calculation. So it's Q equals MC delta T. We will use this one when we have a change in temperature. So that's going to be the easy way to pick this one out. So the problem would say something like we had 75 grams of water at 50 degrees Celsius. It was heated up to 75 degrees Celsius. So we'll be using this when we have a change in temperature. Just like with our other two formulas, Q is heat, and that is measured in joules. M is mass, that is in grams. And C is the specific heat capacity. Specific heat capacity gives us an idea of how easily or difficult it is to heat something up. So, specific heat capacity is the amount of energy needed to raise the temperature of 1 gram of the sample by 1 degree. So water has a value of 4.18 joules per gram Kelvin. So what that means is if we have water and we heat up 1 gram of water and we raise the temperature by 1 degree, it takes 4.18 joules of energy. Since we're going to be talking about changes in temperature, remember a change in Celsius is actually equal to that in Kelvin. So if the temperature goes up by 20 Celsius, it also would go up by 20 in Kelvin. All right, in example number 1, we are solving for joules, so we are solving for heat. Does it take to raise the temperature of a 5-gram sample of water from 293 to 370? So that is our huge sign that we are MC delta T. So since we have our change in temperature, our mass is going to be 5 grams. C, the specific heat capacity for water, has a value of 4.18 joules per gram Kelvin. That is on the front of our reference table on table B. Then you multiply by delta T, which would be 77. So 370 minus 293. All right, then we put that into our calculator. So 5 times 4.18 times 77, that gives us a value of 1,609.3 joules. We only want two significant figures, so that would be 1,600 joules. All right, number 2, this time we have a 1,000-gram sample of water, and it was in a calorimeter. Calorimeter is just something that we can, like a coffee cup where we can measure the temperature change in. And its temperature is raised by 5 degrees Celsius. How much heat energy was transferred to the water? So we are going to do MC delta T again because we are changing our temperature. So I've got 1,000 grams as my mass. I'm water, so again, I can use 4.18. And my change in temperature is 5. Remember, a change in Celsius is equivalent to the change in Kelvin. So we have 1,000 times 4.18 times 5, and that gives us 20,900 joules. We only want two significant figures, so that would round to 21,000 joules. All right, example number 3. Here we have 17,500 joules of heat are absorbed as a sample of water is heated from 12 to 35 degrees Celsius. Find the mass of the sample. So since we have a change in temperature, that is going to be our clue to use the MC delta T formula. My Q is 17,500. The mass is what I am looking for. Since it's water, I can use the specific heat of water, which is given on the front of my reference table. And my change in temperature is going to be 23. A change of 23 in Celsius would also be equal to a change of 23 in Kelvin. So then I just do 17,500 divided by 4.18 and divide that again by 23. And that gives me a mass of 182 grams, but I only want two significant figures because of the temperature. So 180 grams. All right, in this next example here, we have the mass of our sample of water. And again, it's water, so we can use the specific heat capacity off of our reference table. The water is initially at 305 Kelvin. We are heating it up and we are adding 14,500 joules of heat. We are looking for the final temperature. So what we are going to do is we are going to do MC delta T, and we are going to solve for delta T. And then once we know our change in temperature, we knew our initial temperature, and we can find our final temperature. So we have 14,500 joules of heat, 175 grams of water. It is water, so we can use the 4.18 off of the front of our reference table. And again, solve for delta T. So we put that all into our calculator, and that gives us a change in temperature of about 19.8 Kelvin. So our original temperature was 301. So T1, 305. So our original temperature was 305, and we heated it up by 19.8. We know our temperature is going to go up because we are heating it. Therefore, my final temperature would be 305 plus my change, so 324.8, which would round to 325. So again, we solve for our change in temperature, and then we added that to our original temperature. Had we been cooling our sample, then we would have subtracted it from the original temperature. Lastly, I just want to mention that sometimes you would get a problem where we're heating it at a certain rate for a certain amount of time. In that case, you would just multiply the time by the rate. That is shown in this example here. So we have a solid being heated at a constant rate of 150 joules per minute for 3 minutes. How much heat is absorbed? So we would just do the 150 joules per minute times the amount of time we heated it for, which is 3 minutes, and that would give us 450 joules. All right, now that previous problem was super easy. And it would be rare that we would get something that easy. You know, I would never want to insult your intelligence. So it would be more likely that you would see that last problem kind of worked in with a normal heat calculation. So that's what we're going to look at right now. So in this problem, we have 150 grams of a liquid. So this isn't water, so we can't use 4.18 off of the front of the reference table. It's just some other liquid. It's heated at a constant rate of 200 joules per minute for 6.5 minutes. The temperature of the liquid increases from 23.1 to 36.4 degrees Celsius. Calculate the specific heat capacity of the liquid. So I know I'm going to be doing the MC delta T formula, and I'm going to be looking for C, the specific heat capacity. I know my mass is 150 grams. C is what I'm looking for. My change in temperature, that would come from the 36.4 minus 23.1, and that is 13.3. Now, what I'm going to do for my Q, that is going to come from the 200 joules per minute times 6.5 minutes. So my Q has to be joules. So I have to figure out over the 6.5 minutes how much heat has been added. So 200 times 6.5 would give me 1,300. So that is what I am putting in here. So see how we combined the rate problem with one of our normal equations. So now that we have that set up, we do the 1,300 divided by the 150 divided by 13.3, and our C, specific heat, is 0.65, and units would be joules per gram degree Celsius.